All right. Okay. Good evening, everyone. Uh, just want to let you know that I'm signing in from my home. There could be internet issues. I may drop off, so you may have to bear with me. I'll join in case if my internet connection goes bad, and so just bear with me. And I also hope that you got an opportunity to review today morning's code to some extent, especially those of you who have some problem. I'll go through it again, but still want to, but still I hope you got an opportunity to review uh, the ideas discussed in the morning class. Close folder. It's okay. So this is the code that we are looking at, and the so what we have here is we would like to store uh, information about so squares. When you want to store information about a square, all you want to know is its length. And so rectangles, you want to know the length and breadth. Three triangles, three sides of the triangle. And so we want to encapsulate, and then we want to, so the way we would like to do is, we would like to use a structure uh, which tells us a structure which tells us what is the geometrical object that we are working with, whether it's a square, rectangle, or triangle. So the field on line 7, it holds the shape. It holds the shape of the object that we are storing. And here, in order to hold, in order to capture, or in order to store the what is the object that we are holding. So we have introduced what is called as an enumerated data type. In the absence of, we will see what enumerated data type in a moment. In the absence of this, what would we do? We would use something like maybe int or short int shape. We will use something like this. And then what we do is, hash define square is 0, hash define rectangle is 1, hash define triangle 2. So when we read something, like for example here, uh, we will use here, yeah, same here, like what we will have is, we will have something like s dot shape is equal to square, something like this we will do. Isn't it the case? Are you with me here? This is how we will be doing, right? So we are storing what is the object that we are storing uh, in that particular structure by using a variable called shape, and we have this all these hash defines: square, rectangle, triangle, etc. Uh, but a more elegant way to do it is to define a new data type, uh, like what we are doing on line 7. So we call it as enumerator data type. So we defined a new user defined data type called as shape. And what the C compiler do is we can just use square, rectangle, and triangle wherever uh, Due to line 7, I am not sure whether the compiler looks at square as a on line 7 as a reserved word, but it has special meaning. That's true. It has special meaning. So instead of this particular approach, which is that we have taken, using hash defines and the declaring the type of the variable shape as int, all this looks little bit less elegant, although it works. So we kind of took an alternate approach. The alternate approach is defining this new enumerated data type shape, and so we have a variable shape starting with smallest, which is of type capital shape. And the other thing that so once we know this is the object type, so we want one of these three fields will be activated. One of these three fields will be activated. The first question is, how do we, let's say, if you have something like object S, then if you have something like object S, and if you want to access the field shape, the particular way in which we do is we just say S dot shape. This is how we can access this field. And once we know the shape, then depending upon the shape, one of these three should be activated. This is length. I just use R, the variable R or the variable T. The type of the variable R is struct rect, and the type of the variable T is struct triangle. So one of these three will be activated. So how do we access this structure? So R, the way we access this structure R is S dot R. The way we access this particular structure is no, it's the way we access this is not S dot R. Let me, where is this? Yeah. Yeah, the way we access is this by using S dot X, because this whole thing, this whole union, it is part of this outer structure. So we use S dot X dot R, and we use X dot T. And within this, if you want to access length, we use S dot X dot R dot length dot dot S1, so on and so forth. Are you with me on this one? That what are the members of the, how many members are there in the structure? How many members are there in the structure? In the struct object, how many members are there? There are two members. There are only two members in the struct, in the object structure. So one is a shape and the other is a union. Just give me a minute. Okay, sorry guys, yeah, I'm back. So this is what happens if I log in from home, but it's okay. Yeah. So yeah, what do we have? So the structure contains two members. One is shape and the other is union. So you can access this shape using S dot shape, and we can access this structure using S dot X. Maybe I can draw something like this. This is one is S dot shape, other is S dot X. But here S dot X is a union. Uh, so S dot X is union, and it has multiple members in it. So one is s dot x dot length, other is s dot x dot r, and yeah, so other is s dot x dot t. And so further we can go down here and say, like, for example, s dot x dot r dot length, like this. This is how it goes. Or we can have x dot r dot breadth. I hope you are with me in this picture. Are you with me in this picture? S is equivalent to the object. Yeah, that's true. Are you with me in this picture? I hope if you get this tree structure, then I'm very happy. Yeah, great. So now let's see. What do I do? Clear all my drawings. Let's go. And now, so here this is what we do. So let's say if it is square, then I will say s dot shape Yeah, so this is good. So this is how we can have a square, or like for example, if you want to access a rectangle, then s dot shape is equal to rectangle, and s dot x dot r dot length is equal to, let's say the length is 10, s dot x dot r dot height breadth is equal to 20. Like this we can have. Yeah, that's true. So now we have a way of accessing. Uh, so we have a way of accessing the know what shape it is, which fields among in union there are three fields at any point in time. Only one of them is active, and which one is active depends on what is the shape that we are holding. So this flag will tell us which one of them is active. And I have a question for you. What is the size of this object structure? What is the size of this? What is the size of this object structure? How much memory is occupied by the shape? This variable, how much? It would be interesting. Maybe it may, I don't know, it could be 1 byte, maybe line 13. I don't know how much memory it will take. Yeah, maybe 1 byte, maybe 13 bytes. So this length takes 4 bytes, and this structure takes 8 bytes, and this one takes 12 bytes. So overall, this union occupies max of 4 comma 8 comma 12, so which is 12 bytes. 12 bytes of memory will be given to this union, and then possibly one more byte for the shape, plus 1 byte for the shape. So shape may require 1 byte. So overall, I am expecting 13 bytes. So let's see if we are right. Okay, so let's clear all my drawings. Let's see printf size of object equal to %d /n So GCC union 2. Okay, let's see what happens. It is giving 16. Yeah, it looks like it is enum is 4 bytes. So because of that, it is 16 bytes. But it looks like an inefficient encoding, but maybe it's okay. Yeah. So are you all with me here on this? How this whole thing? Length is 4. This is 8. This is 16, and shape is 4 bytes. So union takes max of 4 comma 8 comma 12, which is 12 bytes. 12 bytes plus the size of shape, which is 4 bytes. Overall 16 bytes. So now let's see how this whole thing works out if we do GDB on it. GCC minus G union 2.c GDB a dot out. So if I print S, so I think at this point, when I print S shape, it says it is unknown, and X is the union. So yeah, you can see, that's 12 bytes are allocated to the union, and I want you to pay attention here. I want you to pay attention here. So it just so turns out that S1 is equal to some random value, and S2 is equal to the random value, and S3 is equal to random value. So what happens is, if you just look at this whole structure, the memory of the structure, so this is shape. So shape is present in the first 4 bytes, and then after that there are three words. What is three words? Three words is 4. Yeah, this each word is 4 bytes. So here it is. It so turned out 32767. There is no particular reason why it is here. No, it's just a garbage value, and there are multiple ways of interpreting this whole three. One is if you use if it is simple square, then it will be like L. So only this one will be active, and on the contrary, if it is a rectangle, then we will have length followed by breadth. So remember, breadth will corresponds to this, and then if it is a triangle, it is S1, S2, S3. So because of this, if you see, if it is a simple square, the first word contains this, and we are getting length is equal to this. If it is a rectangle, it has length and breadth components. Because of this, these two are active. And if it is a triangle, we have all these three components. So we have uh, yeah, they should be junk values, but we don't have. 0 is also a junk value, maybe. Yeah, so it's not guaranteed. It's not guaranteed. Are you with me why we are getting this particular output on this line? How many of you are with me? I hope you're all with me here on this one. Great. So nice then. So now let's keep going. Uh, so next square. Yeah. So now let's do this again. I will do print s. So if we print now, you can nicely see it's yeah. So it's a square, and so this field is active. So great. But then you can also see if you interpret the same memory as rectangle, this is how it looks like. And if you interpret it as a triangle, this is how it looks like. So this is, I really want you to learn how to use GDB and play with GDB and see how things are working under the hood. So now next, yeah, let's see, Control L, print this, great. Next, print this, you'll see this, nice. So Rajesh, at the very beginning of the course, I have provided GDB cheat sheet. All you need is the GDB cheat sheet, which is already posted on the course Moodle. Look at the course Moodle, it's there already. So this is how unions work, and this is how we can use our unions. So let's say uh, I didn't give a name to the union. That's true, because I didn't give a type to this union, because yeah, that's true. Pramod has this question on line 15. I didn't say union, no, uh, something like I didn't use anything here because I know we will not be using it this union outside of the structure, so we just left it there without it. Good. So the advantage that you have is, let's say if you are, if you instead of using this, if you just use, instead of union, if I use structure, what will be the, if I use structure here, what will be the memory of required? Can you tell me the memory required? In the first case, the memory required is 16 bytes. If I use union, the memory required is 16 bytes. And if I use struct, then it is 28 bytes, it looks like. So 28 bytes is almost twice the size. Okay, if you kind of think, so there is a 100% increase in the size. So if you are storing 10 power 6 records, if you are storing 10 power 6 objects, then what happens is, no, and you will, by using the structure, the memory required will approximately double. I want you to understand this particular thing. Okay, I'm back. Sorry. Uh, can you hear me? Yeah, tomorrow when I take the class tomorrow, I'll come to office, so this will not happen. So let's go back. Uh, so here, so this is about structures and unions, and there are a couple of things we would like to do in for the rest of the session in today's session. The first thing I would like to do is introduce the idea of function pointers. Just like variables have code, just like variables have addresses, so functions also have addresses in the main memory. So let's do this. Control A, Control C, Control S, fptr dot C. So, we have seen many times this particular picture that we have the whole memory, and so in the memory, somewhere OS operating system kernel will be present, somewhere BIOS will be present, data will be present, and code will be present, and there is a stack, and there is a heap, all this. Uh, so your code, so if I kind of leave the whole thing aside and kind of blow this up, just look at the code. So this is your whole memory, and so your code is also like so somewhere the instructions associated with your main, they will be present one after the other at different memory addresses. And in fact, if you see in the previous, when we were trying to do this GDB on GDB a.out break main to enable, you can see that there is a breakpoint at 0x1149. That is the address at which the first instruction of the main is present. That is the address at which the first instruction of main is present. And if I do something like disassemble, yeah. So if you see this disassemble, so at these are the instructions of the main function, and the first instruction of the main is present at this address, and the second instruction is present at this address, the third instruction is present at this address. So, and these are the relative offsets. The relative offset at which the subtract instruction is present with respect to the first instruction of the main is 8. So we have +8. So even functions have addresses. So even functions have addresses. So if I do, so print main, so we will print the address of the main. We will print the address of the main. So if you want to call the main, for example, so there is a way to call main. So we can kind of call main like this. I think we can get into infinite loop maybe. Yeah, I don't know. Print star main. Okay, so let's not get here. Okay, so yeah, but what I would like you to appreciate is, so main is, if you go examine the contents of the variable main, it contains the address of the first instruction of the function. So every function in your program, it will have a address. It will have a. Why do instruction addresses have different sizes? What do you mean? All instruction addresses have the same size, right? Oh, okay, okay. So that is different instructions have different lengths. That happens in some assembly languages, like for example, x86. It has this property that different instructions will have different lengths. So what is the format of an instruction? Like for example, before I go answer the format of an instruction, so like for example, the length of push RBP instruction is 1 byte, whereas the length of the move RSP comma RBP, it is 3 bytes. You will learn this in your CS4 course why this is the case, because uh, yeah, so it depends on what is called as an instruction set architecture. The format also depends upon the instruction set architecture. Let's not worry about these things. All I want you to understand is every function is a sequence of instructions, and every function has a base address. That is the address of the first instruction. That is the address of the first instruction. Great. So now we can use this particular idea to do some cool things. Like for example, let me do this. Yeah. So I want to write this particular thing. So print object or display object. Let's say I have this display object. So what this display object does is it takes an object S, it takes an object S, and it kind of does maybe switch S dot shape. It will do something like this, and it will do something like case square, do something, case rectangle, do something, case what is the third thing, triangle, uh, do something, and so break, break, break. Right? And then what we can do here is in the code for square, we can kind of say, printf it's a square, and lng h length percent d slash n s dot x dot leng h length. Does it make sense what we are writing? And then we can say if it is rectangle, we do this x dot r dot length, and I'm just writing this code before you so that in the exam you know how to quickly get things done. Triangle, this one is equal to percent d, this 2 is equal to percent d. Great. Okay, here. Okay. Great. So here, like for example, we can do display object, yes. And here again, I can do display object, yes. Also printf2 on line 43. Okay, great. Breadth is equal to percent. So now let's compile this program gcc fptr.c and printf. Yeah, so for some reason we are getting this thing, but we will leave it. we can see first when the, so we can see there are two display statements here. Uh, so here the first time when we call display object is depending upon whether the object is square or not, we printed this. And similarly, in the next time when it is a rectangle, so we have a printed rectangle on the screen. So this is great, but there is a much cooler way of doing it actually. Uh, so let's see a cooler way of doing it. So let's say we have this function. So instead of display object, I have this display square. Okay, display square. Uh, so which takes like for example object which takes, so if it is display square, then someone already told me it's a square. So I all I do is I just print this display square. Similarly, if I have something like someone tells me that the object is a rectangle, then what I do is no, I'll do display rectangle. And then similarly, if I have display triangle, so we are writing a series of code which makes things more and more fptr2.c. Great. And great. So here what we do is this is the next level code. So display square, and you call this, and here you say display not object, display rectangle. Yes, display triangle. Uh, what do we do here? Again, we pass this. If you see what we did, this is what is called as a code refactoring. But you might be thinking till at this point, no, it's just we are just kind of making a code beautification, nothing really fancy. Defaults to void home void. This is what is called as code refactoring. And the same thing. So what we did when we moved from here, where everything is in display object, so we have refactored the code. So this is what is called as a code refactor. So it's good. So this is the first level, but we want to go to the next level and see, do more interesting stuff. So what do we do? Let's write one more program. So, and take it to the next level. Are you with me on this code? This is not much. You're all with me on this code, right? Shall I move on? Okay, I hope you're all with me here. Okay, we didn't do anything very difficult. We just refactored the code and make it more modular. That's all we did. But now we do interesting stuff. Now we do interesting stuff now. So here in this structure, so now what we do is we kind of uh, introduce a something called as a function pointer. So now what we do is we have something called an FPTR, and then we say it takes something of type object. A function type is not allowed. So here we are doing to the structure. If you see on line 35, I have declared a variable called as by name fptr, and this fptr, it's a function pointer. It points to a function. It contains the address of a sequence of code, the base address of a sequence of code, such that like for example, if you have some function like void f struct object, then so f contains the base address of this whole function. So this address, this fptr can hold. So now what we do is, let's do this thing. um, uh, yeah, so here when we are s dot x dot length, so what we do is s dot x dot this is not x dot x dot fptr is equal to display square. So void refers to the return type of the function. Void refers to the return type of the function. Great. And similarly here, so we will have something like I want you to pay attention here. FPTR is a function pointer. It can hold the address of a function which returns a void thing and which takes a parameter of type struct object. On line 35, we are not declaring a function, we are declaring a function pointer. FPTR is a function pointer. Are you all with me? That means FPTR is a function pointer. It can hold the address of a function. Just like variables have addresses, functions also have addresses. Yeah, the syntax of function pointers is bit nasty. So this void refers to the return type of the function which it is pointing to. Like for example, here we want fptr to point to display square or display rectangle, so on and so forth. So because of this, and the return type of these functions is void, so because of that we have void. And it is taking this object as parameters. So because of that, we have a struct object here. Yeah, I think uh, Lakshmanan has got it right. We can't make one function pointer. So let's get the basics right before we have no, we will do things. So let's get the basics right, and then we will its size will be something like maybe 4 bytes or 8 bytes or something. So just hold hold uh, hold on for a moment. So here if you want to call this particular function, so what we have to do is star s dot fptr, and we pass s as the parameter, because that's what we want to. Similarly here also we do the same. So here on line 75, when we call, this is how we call the function This is how we call, things are getting complicated, I understand. So here, this is how we call this function. And so, yeah, so here we are calling the display square function, and here we are calling the display square function, and here we are calling the display rectangle function. On line 81, oh yeah, we are calling display square. Yeah, that's true. That's true. Yeah. So I have one small problem. Let's see. I want to check whether it is whether it throws any error or not. Okay, let's see what happens. Okay, it's working all right. So here on line 75, we are calling the display square function, and on line 81, we are calling the display rectangle function. How many of you understood the code sequence so far? On line 74, we are not calling any function. The address, display address, it has display square. It contains the address of the display square function. So that address we are assigning to FPTR. So display, so let's keep going. Let's see. This is what happens. Let's use GDB and see what is going on. What is the name? GCFPTR2. GCC. Uh, GCC minus G FPTR 3.c GDB a dot out break main run re-enable next next. So let's see p print s dot fptr before this statement. Fptr is pointing to something. I think yeah, I don't know why. Yeah, it's a bit weird, but anyway. So let's see what the display square is. Okay, so now after this, the address of the display square function is this is the address of the display square function, and that we are assigning to the function pointer fptr on line 74. So now if I print s dot fptr, so you can see that fptr now contains the address of the display square function. Are you with me here? That what is happening on line 74, did you understand what is happening on the line 74? Did you understand what is? I hope you are with me on what is happening on line 74. So if fptr is a function pointer, then the way we call that it is by using star fptr, and then whatever the parameters that we would like to pass. This is the actual call. This is the actual function call. This is the actual function call. I'm seeing silence in the chat windows. You are all tired for the day, or are you with me on how a less dot f star fptr? It doesn't work, Pramod. No. I have a doubt. So if we can do, I think is it possible to do s dot fptr of s? Will this work? Maybe even this will work. Let's see what happens. This is what is being asked. GCC fptr3.c dot a dot out. Yeah, so if you are happy using this, no, this particular syntax on line 76, even that is also fine. Today only I read this kind of syntax is also possible. So on line 76, we are calling, no, s.fptr and we are passing the parameter. Okay, so Tanmay has finally asked this question. All of you would be wondering, you are just making a mess of our minds, but we don't see the point of this story, right? So, yeah, so, uh, yeah, so let's make this more interesting. So, why this could be a nice thing to do? Uh, so let's say we have in the function main. Uh, so what we would like to do is, in order to make it slightly more simple, let's say we have a global list of objects. And just now, so let's say hash define max underscore list underscore size. Let's say we are reading some 20 objects. So maximum we want to maintain an array of objects. We want to maintain an array of objects. So here what we do is object uh, objects. Uh, so and then here we have max underscore list underscore size. And then what we do here is, and then let's say there is some variable which keeps track of int uh, list size. This is some variable. So I'm making this more interesting so that we can understand why the point of this whole story. And so int list underscore size, and then we would like to write a function void read objects function. So this read objects function reads objects from a file. Yeah, that's true. So we can, so now on, so can someone tell me, let's say we would like to read objects from a file, and and then we would like to read objects from a file and store it in that list. Can someone help me out in the code here? So let's say it is given in some objects.txt. Okay, so file star fp. So what we have is fp is equal to fopen uh, objects.txt, and we read it in a read-only mode. And what do we do? So while fscanf fp %d ampersand shape is not equal to end of file, we do this. And if so switch shape case square I want you to closely observe the code that I'm writing uh, and help me fix any bugs that I may have introduced. Can someone create a test file for me? Rectangle, square, rectangle, and what is the third shape that we have? Triangle. And int shape. Yeah, parenthesis around shape. Great. So if it is square, then what we will do is we will, and also we will have three things: int len gth, length, breadth, int s1, s2, s3, and int list size is equal to 0. So what do I do? So if it is not equal to 0, then I will say list underscore size plus plus. If it is a square, fscanf fp Aaron has sent me a file to square, rectangle, and what should I do? Format document. So what else I need to do here? Objects list underscore size dot length is equal to, is it length or x dot length? You are little lost, huh? Vivek? How many of you with me are following what I'm trying to do here? We are just trying to. So what are we trying to do? We are trying to read stuff from file. I'm just writing the code along so that you will have time to think what I'm doing. So pay attention. Okay. Are you with me? I hope you're all with me. Do you understand this code? Let me use the code, the file uh, home Rini triple IT. Let's see uh, courses structures. Yeah. Why I am not able to store here? I'm not able to open. Yeah. We will get there. Oh, why not a function pointer for? Nah, point. But so how do I read the file? I'm not able to download the file sent by Jatin. I'm not getting the download option. Can you just paste, cut, copy, paste the file here maybe? Huh. But it's all in the same line, right? Does new line works? Zero. Okay, let's see. Don't I need a new line there? Or yeah, new line doesn't matter. But in order to make it clear, so like for example here, so 0, 10 uh, is 0 indicates it's a square. So there is only one thing, that is 10 is the length of the square. We have one more square. So we have one more rectangle. So one more rectangle, square, triangle, so on and so forth. Just want to see that everyone are with me. So if it is a rectangle, then we will have two following parameters. If it is square, then we will have, no, yeah, one. If it is triangle like this, 290, 0, 0. You have a triangle with two lengths 0. Okay. Yeah, so go crazy. Not bad though. Thank you. 0. Why do I have 2, 1, 90, 90? Okay, great. Are you with me on this text file? Line 15 is error. Why is there error on line 15? One means it's a rectangle. Rectangle will have length and breadth, so we are good. No? So if it is 0, it's a square. There should be only one thing after that. If it is 2, there should be after that 3, that is sides of 3 triangles. And if it is 1, there should be length and breadth. Enum starts from 1. No? Enum starts from, no, enum starts from 0. Right? So now let's try to see if we can read these things. So read objects. I hope we don't get a segmentation fault. If we get a segmentation fault, we are in trouble. ECC FPTR4 s dot shape. Where is s dot shape? Oh, okay. Union 2. Sorry. What did I do here? What should I do to kind of undo myself? Okay, great. Thank you, guys. I'm here. So I should do here read objects. Okay, let's see what happens. GCC. There is no problem. Let's hope there is no segmentation fault also. Okay, so now what's the story? Yeah, so So now this is very nice. So far we are good. So this is now what we do. So, so now I would like to change this name to print. Okay. So where am I? Print is equal to display square. On line 53, see what we are doing. We are nicely setting things up. Yeah, my editing skills are bad. So triangle, good. Are you with me here? So now let's see. I would like to write no. So this display objects function. So I have read objects function, and we would like to have display objects function. So void display objects. So how do we write the code for? Can someone help me out here in writing the code for the display objects? Int I is equal to 0, I less than list underscore size plus I. So what do I do? So I have to use objects I dot print, and so, and to this I have to pass objects. I just, in order to make this, yeah, in order to make my life easy, I just made list size as global variable. Bad design, but yeah. Are you with me on this code? Do you think it will make sense? Does this make sense? How many of you are with me on line 78, the code that we have written for display objects? The line in the loop, I will explain. Yeah. So, so why am I getting this error, guys? Display error, display square, all these are undeclared. Huh? Keep those above the function. Yes. Thank you. Or I can have the prototype somewhere. What about me? In the main, I have to call display objects. Yay, it worked. So, yeah, so you see, uh, how many of you are with me on what is happening there? Do you understand the power of what we are doing? So here what we are doing is, this is like those of you who are into C++, now. So this is how we can, depending upon object, when I call the print, if it's a square, then automatically, the print for the square will be, the display square will be, if this will be executed, and if it is like if it is a rectangle, then the corresponding thing will be executed, so on and so forth. The only thing that is not yeah, almost function overloading. The only thing that we I'm not bit happy about is we still have to pass this as a parameter here. The question is, if there is a way to get over this, then it's like you almost got into C++. Yeah. So if we can remove this, no, but I don't see how we can remove this, because the print function needs the address. So, and also one more thing I want to do. Let's say if you want to do a similar thing. Now here we have, like for example, uh, we can also have, like let's do this. Uh, we can even do this. We can have the display instead of area square. So you can have area rectangle. You can have area triangle. What is the area of a triangle with if the sides are given? Is there a way to do it? Okay. So for the sake of, I have a simple idea to solve this problem. Yeah, use perimeter. that's that's the problem. That's the way to solve this problem. Yeah. So instead of area, let's use perimeter. Okay. So the square perimeter, square perimeter. I hope you are all with me and appreciate. We are getting extremely powerful, unbelievably powerful. We are. I have to say that s dot uh, x dot length times 4, and perimeter is equal to 2 times and so I will just take few more minutes and then to wind up this session. I know you have an exam, but I thought this is a nice way to end this lecture. Perimeter. Line 49. Okay, line 49. I have to. What did I do there? Display rectangle. I should delete it or. Okay, so now here, good. Uh, I will add one more field here. Perimeter. Awesome. We are good. This is not what I want. So those of you who are a bit lost, no, I just want you to go back and think about these ideas. They are not difficult. You just have to. Are you all with me here on the code? Why can't we use the same? No, we cannot use the same print for the perimeter now. Yeah. So see, let's take a moment, and this is what is happening in the read objects function. This is our read objects function. In this one, we are reading one line. Our objects.text contains one object description per line. So we read one object description. So what we are doing is we read the first field, and based on the first field, on line 76, we read the first field. That field tells whether it is a square, rectangle, or triangle. If it's a square, we read there is a one following field. If it is a rectangle, there are two following fields. If it's a triangle, there are three following fields. Are you with me here? Why we are doing this particular thing? On line 76, we get to know what is the object type. Based on that, we branch out to different cases. If it is square, we read only length. If it is rectangle, we read length and breadth. If it is triangle, we read all the three sides. And then we assign that object to the current object in our array. And then what we are doing is there are two functions here. One is print and other is perimeter. And so we are just saying display square is equal to print, and perimeter for the variable perimeter or the field perimeter, we are assigning perimeter square function. So on and so forth. That's all we are doing. So, and then, so what we are doing here is we read objects, we display objects. So print list of objects /n, print perimeter of objects. So what is the code for perimeter of objects? Perimeter, did we write that code? Sorry. /n before the perimeter of objects. Are you all with me here? How we are computing the perimeters on line 120? On we are just iterating, and we are just so if it is a square, if the object is a square, we call perimeter square. If it is a rectangle, we call perimeter rectangle. If it is a triangle, we call perimeter triangle. So let's compile this code and see what happens. Printf. Nice. I hope you understood what we are doing. What we did today in this last half an hour is extremely powerful stuff, guys. We are leading to object-oriented programming, and almost there. We are almost there for C++, object-oriented programming approaches. So when you are working with, so now let's say if you are working with, if someone asks you what is the area of an object, if someone gives you an object and asks you what is its area, what you have to do is you have to check what is the shape, and if it's the shape is a square, then do this. We have to, your entire code will contain lots of switch and case statements. Are you with me here? If you don't have this, you're wherever you are doing things, you need to have a switch case statement to figure out what is the shape and how you have to deal with it. But instead, what we did, we have only one switch case statement and forever took care of everything else. How many of you understood this point, that instead of having in this particular case, we avoided a switch case statement in display, we avoided a switch case statement in the perimeter. So instead of having, and if you want to do 10 different things, you will have for every function, you need to have a switch case statement. But instead, we have only one switch case statement in the read objects function, and then we are done forever. It's just not modular design. It's no one thing, of course, it's modular design, but uh, but if you want to find the area of an object or perimeter of an object, all you are doing is you're just calling perimeter or area or print or whatever that you are doing. Let's say if you are working with graphics, these objects you want to color them. So how do you can have a different color function for each of these objects. All you have to do is no dot color or dot shade or whatever you want to do, you can do. But all you have to do is in the read objects, you set things up everything, and after that, after you do this thing, you are done for the rest of your life. You don't need to deal with each of these objects using a switch case statement. We So I see the class started with some 50 students. Now it came to 35. So that kind of tells how the class went. So, but I can't help. Uh, so, uh, yeah. So Pramod has this question which he asked a couple of times, but it's okay. I'll respond to your question, but let me see. What is the question? Someone asked something about go through the code, read objects code. All you have to do is very simple. Let me do this. So draw, yeah. So based on the shape, every line, so like so you can have 0 length or 1 length breadth or 2 s1 s2 s3. This is the format of the. So what happens is if the shape, here on line 76, you are reading the first field. Excuse me. And if it is 0, you go here. It is square, so you only read this. If it is rectangle, you read the length and breadth. And if it is triangle, you read S1, S2, S3. This is the first part. And then, of course, if it is square, then you set the shape and the length fields. If it is a rectangle, you have to set shape, length, breadth. If it is triangle, you set S1, S2, S3 fields. So the story doesn't end there. The real power comes after that. On line 84, we are telling if the object is of type square, the print function that you have to use is display square. And if the object is of type square, the perimeter function that we have to use is perimeter square. The same thing here, if the object is of type rectangle, you have to use display rectangle. And if the object is of type perimeter, use the function perimeter rectangle. So the whole, you are setting up the whole stage for the drama that will unfold later. The whole, you're setting up the whole stage for the drama, all the characters, everything, you are all setting up. And once everything is set up, then you can do whatever you want to do later with minimal effort. And that's what we do. So here, so after that, if you can see the display rectangle, so you have, sorry, not this one. you just say display objects. You can compare the code here. This is the earlier display object, where what we are doing is depending upon the shape we are calling this. This is all, and if it is perimetered, if we don't use function pointers, you have to do something similar to this. Depending upon the shape, we have to call the corresponding object's perimeter function. But now, since the stage is entirely set, so if you want to display object, all you have to do is, like this simple loop. And similarly, if you want to compute the perimeter of all the objects, you just have to call this, that's it. So this is the summary of today's lecture. And uh, so this particular idea comes really handy when you are working with file systems later on in your operating systems course. So like, for example, what happens is, you already know a little bit about system calls. Like, for example, your fprintf gets mapped to the write system call. But what happens is, this particular realization of the write system call, it depends upon whether you are working with a FAT32 write or whether it is a ext4 write. These are different file systems. Or whether it is a ext, or like, for example, if ZFS is, I think, another file system. So ZFS write. So different file systems have different write functions. So what happens is, depending upon which file system you are writing, this hooking up of this write with this particular thing automatically happens. So you will understand when you read about file systems in your operating systems course. When you look at this this particular feature, then you will remember. Okay, so I'm setting things up for you so that you will remember me down the line also. Okay, so I'm just kidding, but anyway, so this is very, very powerful, and this is used in all modern file systems. So this is what is called as a, between this and this, we have what is called as a VFS layer. VFS stands for virtual file system layer. VFS layer. So VFS stands for virtual file system layer. There will be a virtual file system layer, so which kind of hooks up the user level write system calls with the underlying file system level write system calls. All right. Uh, so this is one uh, uh, all right, guys. Okay. So let's. Okay, I think this is very, very, very nice idea. Okay, this you will see it later. Maybe in your third semester you will see this, but it's fun. Good. So I will commit this code. I think we should stop here. Time is 7:35, and we should stop here. I will commit this code. I will post this video. I really want you to think about this and completely understand today's lecture. This is a very powerful thing that we have seen today, and it will have wide implication in the way you approach certain kinds of problems. So I will pause here. Okay. Awesome. Thank you, and have a great day. May you do well in tomorrow's exam. And okay. So tomorrow, 2 o'clock, we will meet again. That will be the last lecture, because I don't want the lectures to overflow for the next week. If there are any doubts, I can clarify, but we'll stop. Technically, the last lecture will be tomorrow's 2 o'clock lecture. Okay. All right then. Good night. Thanks to you all. So it's great to be with you on Friday evening. Yeah. Bye.